Hey kids, Miss Kulkarni here. Let's continue with thermochemistry. And in this video, we will discuss enthalpy changes for reactions. So let's begin now. First of all, if a reaction does not have any value of delta H or enthalpy given for that, we can always calculate that value. And what do we need for that? We need to know the standard heats of formation for the reactants and products. So what do we mean by standard heat of formation? This is the amount of heat or enthalpy that is accompanied with formation of 1 mole of substance, and it has to originate from individual elements and all of those in their standard state. Now the meaning of the word standard here is standard ambient temperature and pressure, or we call that as SATP. The conditions for SATP are 1 atmosphere pressure and look at the temperature. It is 25 degrees Celsius. Remember, this is not STP when we have pressure as 1 atmosphere and temperature as 0 degree. What we have over here is SATP. One more thing to remember, the heat of formation for all of the elements in their natural state at SATP is always 0. Let's work on some actual problems now. Alright, so here is our first problem to calculate the enthalpy change in combustion of sucrose, and that's the molecular formula. We also need to predict if the reaction is endothermic or exothermic. And over here in this table, the heat of formations are given for reactants or products. But before we begin, step number 1, we need to write down the balanced chemical reaction. So there you go, we got a balanced reaction. Remember, combustion products are always CO2 and H2O. Now, in order for us to find out enthalpy for the reaction, we need to find out enthalpy for products and enthalpy for reactants. And we do that by multiplying the number of moles by the heat of formation per mole. So products are 12 moles of carbon dioxide. So it will be 12 times the heat of formation for carbon dioxide, which is negative 393.5. Then we get the second product, which is 11 H2O. So 11 moles of water molecules, and the heat of formation for 1 mole is negative 242. When you simplify and actually work on that, the answer which we get is negative 7384, and the unit is kilojoules, because that's what we have for delta H for formation. We repeat the same process for the reactants. There is no coefficient with sucrose, that means it is 1. So 1 time, whatever is the delta H for formation, we multiply those two values. And the next one which we find is oxygen. And if oxygen is in natural standard state, the heat of formation will be always 0. So it is 12 times 0. When you work on that, the total for delta H for reactant comes out to be negative 2226 kilojoules. And now our final step will be to find out delta H for reaction, and that is delta H for products minus delta H for reactants, and we simply subtract the values which we got. And what is the final answer over here? When we solve that, we get negative 5158 kilojoules as our final enthalpy for the reaction. Now, based upon this value, how do we know if the reaction is endothermic or exothermic? I want to remind you that if the reaction is endothermic, then the delta H is positive, and if the reaction is exothermic, then delta H will be negative. So the value of delta H which we got is negative value here. That means the reaction must be an exothermic reaction. Let's move on to the next problem now. In this problem, the balanced reaction is already given to us. But there is one difference. We are given the amount of nitroglycerin in grams. And our job is to find out the enthalpy change for that amount of reactant. The main process remains still same. Our job is to find out the enthalpy change for the reaction. And for that, we take same steps. We find delta H for products and delta H for reactants. So we got in products 6 moles of nitrogen. Nitrogen is the element, so it will be 0. Then we get next one is oxygen, 1 mole. That will be equal to 0. Next one comes carbon dioxide. That's 12 times negative 393.5. And we get 10 moles of water molecules, which is negative 241.8. When we multiply all of that, the answer which we get is negative 7140 kilojoules. Let's repeat the same process for reactants. Reactants, we only have 4 moles of nitroglycerin. So it will be 4 times the amount for nitroglycerin, which is negative 364. And when you multiply, we get negative 1456 kilojoules. And the next step is to find out delta H for the reaction. Same process, delta H for products minus delta H for reactant. So we take these two values and do the subtraction, and the final value comes over here as negative 5684 kilojoules. Now this is going to be for 4 moles of nitroglycerin. So if you want to find out how much will be value for 10 gram, we need to convert 10 gram to moles first. So that value will be the mass divided by the molar mass. And the molar mass for nitroglycerin is going to be 227.1. So we divide 10 gram by the molar mass, 227.1, and that times we need to get the amount of enthalpy per 1 mole. And how many moles we got? We got 4 mole, so we divide that by 4. And the final answer for this comes out to be negative 62.6 kilojoules. Let's work on one more practice problem for finding enthalpy of reactions. So here we begin. We need to get delta H for products and delta H for reactants. The products are 4 moles of NO, and NO delta H for formation is 90. And then the next one is water molecules, that is 6 moles. So we multiply those two, and that one comes out to be negative 1356 kilojoules. Then for reactants, we got 4 moles of ammonia, and for ammonia it is negative 46. And the second reactant is oxygen, for which the heat of formation must be 0. And total for this is negative 184. Then the next step is to calculate delta H for reaction. And that will be delta H for products minus delta H for reactants. And when we work on subtraction, the final answer for this is negative 1172 kilojoules. So what is the sign for delta H? Delta H is negative over here, and if it's negative, the reaction must be exothermic. So look at this. You guys learned how to find the enthalpy of reactions. I hope you guys enjoyed the video, and I will see you again in next video. Until then, bye bye.